All right, boys and girls, welcome to our fourth video lesson in Chapter 12, our lesson on volume and surface area of cones and pyramids. Alrighty. Okay, as we know, the volume of a prism is the area of the base times the height. The volume of a cylinder is the area of the base times the height. Anything that comes to a point, the volume is always going to be 1/3 the area of the base times the height. So anything that comes to a point, such as a cone, is 1/3 the area of the base, which the base of a cone, of course, is a circle, pi r squared, times the height, and make sure you're getting the true height, the actual height, and not the slant height. Okay, you don't want to get the slant height, you want to get the actual height. So the volume of a cone, it equals 1/3 pi r squared h. Area of the base times the height. So let's look at this guy right here. Find the volume of this cone. It has a radius of 5. It has a slant height of 13. It's not the height. So we now know the volume is equal to 1/3 the area of the base, which is pi r squared, times my height. Okay? So we got 1/3 pi. My radius is 5, so that's 5 squared, which is 25, times my height. Now let's look closely here. We have a 5, 12, 13 right triangle right here, 5, 12, 13. So therefore my true height must be 12. So my true height is 12. So I have 1/3. I have 1/3 times pi times 25 times 12. I don't have a calc in front of me, so I'm going to do 1/3 of 12 is 4. 4 times 25 is 100. So I have 100 pi, or approximately 314. Okay, the volume of a pyramid is 1/3 area of the base times the height. As we just said, anything that comes to a point is 1/3 the volume of the prism or the cylinder that it comes into. So picture a prism that this pyramid can fit inside of. The volume of a prism is area of the base times the height, so the volume of a pyramid is 1/3 area of the base, which in this case looks like a square, times the height. Let's try one. So find the volume in total surface area of the pyramid to the nearest hundredth. Let's just do the volume today, since we've already done a gajillion surface areas. So the volume of this pyramid is going to be 1/3. Oh, I need my pen. 1/3 area of the base, which in this case is a square, so it's 8 times 8, times the height, which in this case is 10. So what I have here is I have 1/3 times 8 is 64, times 10, which is 1/3 of 640, which is 640 thirds, which is approximately, or exactly, 213 and 1/3. Looking at this problem right here, Mr. DeWitt is the manager of a theater. He can purchase one of 2 containers to hold a small order of popcorn. Which is bigger, and how much more popcorn does it hold? Round to the nearest tenth. So let's look at this first one. This first one, we have it's just a prism. It's a box. So the area of that prism is going to be length times width times height. And in this side, we have a cone. In the cone, I have a height of 8, and I have a diameter of 6, which means my radius is 3. So here my radius is equal to 3, right? So let's find, first of all, the volume here in the first one. Volume is going to equal length times width times height, which is 5 times 3 times 6. 5 times 3 is 15. 15 times 6, don't tell me. 90, I hope. So there's the volume of the box. Now the cone is going to be 1/3. The volume, of course, is equal to 1/3 the area of the base, which is pi r squared. Pi r squared times my height, which equals now 1/3 pi. My radius is 3, so radius squared is 9 times my height, which in this case was 8. 1/3 of 9, of course, is 3. 3 times 8 is 24. So this whole thing is equal to, I'll do it in green here, 24 pi. I'm going to whip out my calc real quick here. 24 times 3.14 is 75.36. Let's call that 75.4. Clearly, the volume of the box is bigger than the volume of the cone by a total of, I'm doing this math in my head here, how much bigger? 15.6 cubic units, cubic inches. Okay, let's look at this one right here. We got the Great Pyramids of Egypt at Giza. They were built a long time ago, 4,500 years ago approximately. It is a square pyramid. That means the base is a square, and it has a height. What's the volume of the pyramid? Again, I'm going to draw a quick little picture. Okay, so I'm going to have a square base. I'm going to draw it. So I'm looking at, here's my pyramid. Here's the base of my pyramid, like that. It's going to come to a point up here. I'll do this in green so we can kind of see it. It's going to come to a point up here. So there's my pyramid. My bases have a length of 755. It's a square base, so that's both 755. That's a 7, just so we know. And I have a height, of 481. So I know that the volume of my pyramid is 1/3. Area of the base, which is 755 times 755, times my height, which is 481. I'm going to whip out my calc right now. I got 755 times 755 times 481, all divided by 3. And I got a big number. It is, the volume is equal to 91394,008.3. So that looks like 91,394,008 cubic feet. That would be feet to the third, cubic feet. All right, let's do one more. A truckload of dirt is dumped in front of a newly built home. The pile of dirt is cone-shaped. It has a height of 7 feet and a diameter of 15 feet. How much dirt was delivered? I'm going to first draw a little picture. There's the base of my cone, and it goes up like that. I know that the diameter of my cone is 15, which means the radius is 7.5. And I have a height of my cone. The whole height, not a slant height, but the height is 7 feet. So the volume of this cone, to find out how much dirt I have, the volume is going to equal 1/3 times the area of the base, which is pi, times my radius squared, times my height now. So equals 1/3 pi. My radius is 7.5 squared, times my height, which is 7. I'm going to do all that math. I got 1/3 times pi, 3.14, times 7.5, times 7.5, times 7. Whipping out my calc here. I'm not doing this in my head. Doing it on my calc. I get 412.33. It asks us to round to the nearest hundredth. So I'm rounding down to the 0.33. There's my final answer. That's cubic feet. And that, my friends, is a lot of dirt. Hey, we'll see you. Have a good day.